So this is the first session on friction. So in this video I'll take up the some basic concepts and definitions of friction. Okay. Now see, friction can be subdivided into two types. Friction can be subdivided into two types. One is called the fluid friction or viscosity. Fluid friction or viscosity. And second is solid or dry friction. Solid or dry friction. Okay. So in this first video I'll take up this one, solid or dry friction. This fluid friction or viscosity will be discussed in the chapter on fluid mechanics. Okay. Now I'll take up this case, solid or dry friction. Okay, this will be discussed in the chapter on fluid mechanics, but just one line I would like to say regarding it. How do you define fluid friction? Fluid meaning liquids and gases. Liquids and gases are collectively termed as fluids. Fluid friction meaning that when various layers of fluid in contact slip with respect to each other, and the sliding layers exert forces on each other opposite to the direction of relative slip. That is called the fluid friction or viscosity. Okay, but we are not going to discuss this. We are going to discuss this. How to define solid or dry friction? When two solid bodies are in contact, okay. When two solid bodies are in contact, then the friction forces the contact. If two solid bodies are in contact, then the tangential component of contact force between the two bodies is called solid or dry friction. What is this solid friction contact force? I'll just discuss it here. Okay. So it's something like this. See, suppose we are given two solid bodies in contact. Okay. This is solid body 1, B1. This solid body B2, both are in mutual contact here. Okay. Now these two solid bodies B1 and B2 are in mutual contact because of this is the point where the contact is taking place. Okay. So suppose this is the common normal at the contact point, common normal, right angle to the contact surfaces. Okay. And this is the tangent plane at the contact point. All right, fine. So this is this vertical line. This is the common normal at the contact point. Fine. Common normal at the contact point. And this line is the common tangent plane at the contact point. Tangent plane meaning what? A plane surface which touches both the solid bodies at the contact point is called a tangent plane. So this is a common tangent plane. At contact point. Okay. So we'll talk of this. Okay. So B1, B2 are two solid bodies in mutual contact. This is the common normal at the contact point. This is the common tangent plane at the contact point. Okay. Now these two solid bodies exert contact forces on each other in accordance with Newton's third law. This contact force will be denoted by Fc. So this contact force arises because of mutual contact between the two bodies at these points. Okay. Now the body B2 will exert some contact force on body B1, not necessarily along common normal, but at some arbitrary direction. Okay. So let us show it in this way. Fc. So Fc is the contact force on body B1 due to body B2. Okay. And why is it called contact force? Because it arises because of mutual contact between these two bodies. Okay. So Fc is the contact force on body B1 due to body B2. By Newton's third law, body B1 exerts an equal opposite contact force Fc on body B2. Okay. So these are the pair of contact forces between these two solid bodies in contact. And why is it called a contact force? Because it arises because of mutual contact at these points where the two bodies are in contact. Okay. One thing I would just like to say, this contact force is electromagnetic in nature. It's an electromagnetic force. Okay. This contact force arises because the atomic particles of two bodies in mutual contact stick to each other. Okay, so they exert contact forces because of this reason. What is that reason? The reason is that the atomic particles of the two bodies in contact here, they stick to each other because of attractive interatomic forces, and because of this, these contact forces arise. Okay. Now this contact force has a component along the common normal, which is denoted by N, which is just called the normal reaction. Okay, or normal reaction or normal force between the two bodies, normal contact force. So N is just the normal component of the contact forces Fc. Okay, it is the normal component. It is the normal component of contact force Fc, and also obeys the third law. Okay, so normal force on body B1 due to body B2 is this one. So normal force on body B2 due to body B1 is this one in downward direction. It obeys the Newton's third law. Now Fc also has a component in the common tangent plane. So this component of Fc in tangent plane is noted by small f. This is the friction force. Okay. So friction force also obeys the Newton's third law. So B2 exerts friction force F on body B1 in this direction. By Newton's third law, B1 exerts equal opposite friction force F on B2 in opposite direction. So this friction is the tangential component of the contact force Fc between the two solid bodies in contact. Okay. So F is called the friction forces between the two bodies. Between the two bodies B1, B2 in contact. The two solid bodies B1 and B2 in mutual contact. Okay. And this friction force is the tangential component of the contact force Fc. Fine. So friction force is the tangential component of contact force Fc. Okay. So friction force is the tangential component of the contact force Fc between the two solid bodies B1 and B2 in mutual contact. Is it clear? Fine. So this friction is this friction which we have defined here. This is just solid or dry friction. So friction force existing between two solid bodies in mutual contact is called solid or dry friction. Fine. Friction force existing between two solid bodies in mutual contact, okay, is called the solid or dry friction. Okay. This friction force we are going to discuss in this chapter. Fine. All right. See, one thing I'd like to say in the beginning. First, I'll just state the basic definitions and concepts. Then I'll take up numericals on kinetic friction. They are fairly straightforward. Okay. And then I'll take those type of questions which are very important theoretically in friction chapter. There are several blocks are given one above the other. External horizontal forces being applied to one block. Friction coefficients are given. We are asked to find the acceleration of each block and the friction forces between the blocks. So they are very important class of questions. Okay, a substantial concept is involved there. So that also I'll take up in the coming videos. But first I'll describe all the basic concepts. I'll state them. Then I'll take up numericals on kinetic friction. Then I'll pass over to that problem. And finally I'll take up some miscellaneous problems on friction chapter at the end. Okay, fine. So it's a very important conceptual chapter. Okay, fine. I'll grab this one. Okay. So now, see, solid friction can be divided into three types. solid friction or dry friction. Yeah, simply friction. Okay. Three types. First is kinetic friction. Okay. Kinetic friction. Various names. Yeah, sliding friction. Or dynamic friction. These are the various names. So the one category of friction is kinetic friction, a sliding friction or dynamic friction. They all mean the same thing. Next is the static friction. Static friction. Which will be denoted by Fs. And kinetic friction will be denoted by Fk. And third is rolling friction. Rolling. Okay. Denoted by Fr. Okay. But in this chapter, we will be interested only in these two, not this one. See, questions are not asked on rolling friction. Okay, they are not asked. Questions are asked mainly on this and this. So we will be interested in these two aspects of topic types of friction: kinetic friction and static friction. Fine. All right. So now first, I'll define what is meant by kinetic friction. Fine. I'll rub this. Fine. So we will first talk of kinetic friction. Okay. Kinetic friction, which will be denoted by Fk. Now, how do you define kinetic friction? See, kinetic friction is defined in this way. Suppose we are given two solid bodies in contact, solid body 1, B1 and solid body B2. They are in mutual contact here, okay? This is the contact surface where two bodies meet each other. Suppose with respect to B2, B1 moves rightward. With respect to body, solid body B2, all the material points of B1 in contact with B2 move, suppose, in rightward direction. This means there is relative slip taking place between the two bodies at the contact points. In this case, body B1 and B2 exert equal opposite contact forces on each other, and the direction of contact force is opposite to the direction of relative slip. That is, with respect to B2, B1 is slipping that direction. So, B2 exerts a kinetic friction on B1 in direction opposite to the direction of relative slip. And by Newton's third law, body B1 exerts equal opposite contact force Fk on body B2. So, this is the contact force, okay? Kinetic friction, okay? So, how do we define kinetic friction? Two solid bodies B1 and B2 are given. They are in mutual contact, and relative slip taking place between B1 and B2 at the contact points. In this case, I have assumed that with respect to B2, the material points of B1 in contact with B2 are slipping rightward. So with respect to B2, B1 is slipping rightward. So B2 exerts a kinetic friction Fk on B1 in direction opposite to relative slip, that is in leftward direction. And B1 exerts equal opposite contact force Fk on B2. Okay, so this is the kinetic friction. So how do you define kinetic friction? Force of friction between two solid bodies B1 and B2 in mutual contact and relative slip taking place at the contact point. Then the friction which acts is called the kinetic friction. Okay. So how do we define kinetic friction? Force of friction between two solid bodies B1 and B2 in mutual contact and relative slip taking place at the contact points. Okay. So this is called the kinetic friction or sliding friction or dynamic friction. Various names. Alright. So Fk is the force of friction between two solid bodies B1 and B2. B1 and B2 in mutual contact and relative slip taking place at the contact points. Relative slip taking place at the contact points. This is called the force of kinetic friction, denoted by Fk. So kinetic friction always opposes the relative slip taking place between the two bodies. Okay. So this means that, for example, this is the body B2, this is the body B1. Suppose all the material points of B2 are moving rightward, say at 4 meters per second. Suppose this is a table surface, okay, and here there is rough surface, and all the material points of B1 are moving rightward with say 5.5 meter per second, suppose. Then with respect to B2, B1 is slipping rightward at 1.5 meter per second by concept of relative velocity. So B2 will exert a kinetic friction on B1 in leftward direction, opposite to the relative slip of B1 with respect to B2, this one. And by Newton's third law, B1 will exert equal opposite kinetic friction Fk on B2. So this kinetic friction always opposes the direction of relative slip between the two solid bodies in contact. Okay. So two solid bodies B1 and B2 are given, which are in mutual contact, and relative slip taking place between these two bodies at the contact points. Then the two bodies exert kinetic friction on each other opposite to the direction of relative slip. Okay. So in this example, with respect to B2, B1 is slipping rightward at a velocity of 5.5 minus 4, 1.5 meter per second. So B2 will exert a kinetic friction Fk on B1 in leftward direction. And by Newton's third law, B1 will exert a kinetic friction Fk on B2 in rightward direction. So kinetic friction always acts in a direction opposite to the direction of relative slip. Alright. Always acts in direction opposite to the direction of relative slip. Direction of relative slip. Okay. Actually, one thing I'd like to say, it's a wrong concept that many people think that kinetic friction always opposes the motion of the object. No, it opposes relative motion, not the actual motion itself. It's wrong to say that kinetic friction always opposes the motion. No, there are many instances in which the kinetic friction increases the speed of an object. So be careful about it. Okay, you don't say it's a wrong motion. People say that kinetic friction always opposes the motion of object. No, that's not correct. There are many cases in which kinetic friction can increase the speed of the object. Okay, this I'll take up some numericals of this type, but since I've spoken of this quantity concept, I'll just explain it by means of example. Okay, see what I'm saying, that it is not that kinetic friction always opposes the motion of object. No, it opposes the relative slip. See, I'll take some example. I just to demonstrate this concept, I will take up an example here. Suppose here we have a smooth horizontal surface. There is no frictionless surface. Okay. Here we have a plank. All right. Fine. And here there is a block. Okay. Suppose this surface of contact between block and the plank is rough. Okay. Now suppose I give a velocity of say 6 meter per second to the block up in rightward direction with respect to ground. Okay. And here I assume to be frictionless surface, smooth. This block plank is initially at rest, and this block is moving rightward at 6 meter per second with respect to ground. So you see here, this block and plank are in mutual contact, and with respect to plank, the block is initially slipping rightward. So by the rule of kinetic friction, plank will exert a kinetic friction on the block Fk in direction opposite to relative slip, that is in leftward direction. And by Newton's third law, this block will exert equal opposite kinetic friction Fk on the plank in rightward direction. Plank was assumed to be at rest initially. Okay, initially the plank was assumed to be at rest. Now see, this plank exerts kinetic friction Fk on the block in leftward direction, and by Newton's third law, this block exerts Fk on plank in rightward direction, Now you can see that here we are assumed to be smooth. In the influence of this kinetic friction, the speed of this plank will begin to increase. So it's wrong to say that kinetic friction opposes the motion of the object. No. It only opposes relative slip, not the actual motion itself. Is it alright? This question can be asked in JEE Mains in advance. True, false type or matrix match type, we can ask such questions in theoretical questions. This point should be noted down. It does not oppose the actual motion itself, not always, but it opposes relative slip. Okay? It need not oppose the motion. Don't say that it opposes the motion, no. It in general opposes the direction of, it opposes the actual relative slip between the taking place between the two bodies. Fine? Alright? So, regarding kinetic friction, I have told you this many points. Okay. Now, there is a law of kinetic friction. Okay. Law of kinetic friction. So let Fk denote the magnitude of kinetic friction, Fk. Okay. It is the magnitude of kinetic friction. Fk is the magnitude of kinetic friction. Okay. So there are two laws of kinetic friction. First is this. This magnitude of kinetic friction is equal to mu kn, where n is the normal contact force between the two bodies B1 and B2 in contact, and Fk is the kinetic friction acting between two bodies B1 and B2, and mu k is the proportionality constant. It is called the coefficient of kinetic friction. Okay. Coefficient of kinetic friction. Or coefficient of sliding friction, or coefficient of dynamic friction, various names are there. Alright. And this mu k is a non-negative quantity. It's a real number, it's a scalar quantity. And value of mu k is a joint property of the two surfaces in contact, of the two solid bodies. Fine. I'll write this one, okay? See the video, I would like to say one thing. See the videos which I am making, they are complete. If you study from this video also, then you don't have to go anywhere else. That's why I am emphasizing it again and again. Whatever chapters I have put on this video, in my channel, if you go through them, you don't have to see any other book. It's sufficient, everything, complete thing, for board, mains, advanced, everything. It is in these chapters. So this you must note, okay, fine. So mu k is a non-negative quantity, and value of mu k is a joint property of the two surfaces of the two bodies in contact. It's a joint property, okay. Its value depends on the nature of surface of the two solid bodies in mutual contact, okay. And it also depends on the degree of roughness or smoothness. More the rough the surfaces in contact are, more the value of mu k. Less rough, less the value of mu k. Okay, fine. And one more thing, it's wrong to say that mu k is always less than 1. No, it's not that. Mu k can achieve any value between 0 to infinity. But in problems, we very rarely encounter those cases in which mu k exceeds 1. But don't think that mu k always should be less than 1 itself. No, it can be any non-negative value. It can more than 1 also. Mu k may exceed 1. There is no hard and fast rule. Okay, fine. So mu k may exceed 1. Mu k may exceed 1. Okay, fine. N is the normal contact force between the two solid bodies B1 and B2 in mutual contact. Fk is the kinetic friction between the two bodies B1 and B2, and mu k is the coefficient of kinetic friction, which is a non-negative quantity. Its value depends on the joint property of the two surfaces in contact, and mu k may exceed 1. Okay, and mu k is a non-negative quantity. Okay, its value depends on the type of the. Its value of mu k is a joint property of the two surfaces of the two bodies in contact. Fine. More the degree of roughness, more the value of mu k. Less the degree of roughness, lesser the value of mu k. But mu k may exceed 1 also. Fine. So this is the first rule. This is called the law of kinetic friction. Okay. This is called the law of kinetic friction, first law. Now say one more thing. There's one more thing. There's one more thing, see. See, second law is this. But see, numerical very frequently less time we encounter the case 2. From numerical point of view, this is very important. Okay, fine. So second property first I'll state it for sake of completeness. Let's suppose this is a rough table surface. Okay, here we have a cuboid or cube. Okay, fine. Now, if the surface conditions are same, so suppose this block is sliding over this table surface. Okay, rough table surface. This block is sliding over this rough table surface. Fine, it's sliding. All right. It's a rough surface. This table surface is fixed. So this table surface exerts a kinetic friction on this body opposite to direction relative slip, that is in leftward direction, Fk. Value of this Fk will be equal to mu k by mu kn, as I've stated just now, first rule. Okay. Now one thing I would like to say, see, if the surface conditions between the table surface and any surface of the block are identical, then the force of kinetic friction will be independent of the macroscopic contact area between these two bodies. Value of Fk is independent of the macroscopic contact area between the two bodies in contact. Fine, alright. So Fk is independent of the macroscopic contact area between the two solid bodies in mutual contact. Of macroscopic contact area of the two surfaces in contact. What do you mean by two surfaces? The two surfaces of two bodies, solid bodies, which are in mutual contact. These are the two laws of kinetic friction. Okay. First law is this: magnitude of kinetic friction is mu kn, and second, force of kinetic friction is independent of the macroscopic contact area between the two bodies in contact. This means that if you place this surface in contact with this, kinetic friction has certain value Fk. Suppose what I do, I rotate the body. So I put body like this. Now this surface comes in contact with the surface. Here again this body is slipping rightward. This table again exerts same kinetic friction Fk on the body in leftward direction. These two kinetic frictions are same, even though the macroscopic contact area is different. I hope it is clear what I am saying. That is, suppose is it clear? Just a little bit, okay? See, I'll just explain it much more. Suppose I draw the 3D view of the object. 3D view, okay? This object lies on this rough table surface, okay? Suppose this area is, say, A1, say 50 centimeters square. This is the macroscopic contact area between these two surfaces. And suppose this area is, say, 100 centimeters square, okay? Now suppose we assume that the surface conditions are same between this surface and this table surface, and this surface and this table surface. Surface conditions are same. So this means that suppose this block is slipping rightward with respect to the table surface. This table surface exerts kinetic friction on the block Fk opposite to the direction of relative slip. Fine. Now what I do, I rotate this body. Same table surface here as was here. I rotate this body like this, so body becomes like this. See this one. Now the macroscopic contact area is this much, 100 centimeters square. In this case, the macroscopic contact area was this much, 50 centimeters square. Now suppose this block is made to slide on this table surface, same block. This block I have rotated like this. I have turned it for 90 degree and placed it here. And it is again sliding on this rough table surface as it was sliding here. In this case also, this table surface will exert the same kinetic friction Fk on the body. So in both these cases, the kinetic friction of block due table surface is same, even though macroscopic contact areas are different. This is the macroscopic contact area in first case, which is 50 centimeters square, and here it is 100 centimeters square, the macroscopic contact area. So in both these cases, macroscopic contact areas are different, yet the kinetic friction on the block due to the table surface is same. So these are the two laws of kinetic friction. All right. So in this first video of this friction, I have explained the basic friction. Two types of friction are there: solid friction and fluid friction. I have just formally defined what is fluid friction. That will deal in later in the chapter on fluid mechanics. Then I have defined solid friction or dry friction. Then I have told there are three types of solid friction: kinetic friction, sliding, static friction, and rolling friction. Kinetic friction is also called dynamic friction or sliding friction. Static friction is denoted by Fs. Rolling friction is denoted by Fr. Kinetic friction is denoted by mu k or Fk. Alright. Now I have also stated that we will deal primarily in this chapter with kinetic friction and static friction. Then I have stated the laws of kinetic friction. Kinetic friction Fk is the force of friction between two solid bodies in mutual contact and relative slip taking place at the contact points. And this also I have stated that kinetic friction always acts in a direction opposite to the direction of relative slip. This also I have stated that it is wrong to say that kinetic friction always increases the speed of object. No, it only opposes relative slip. It is possible that kinetic friction can increase the speed of object. I gave the example of that block and plank. You can see in this video itself. And I have also defined what is contact force. Why does it arise? It's an electromagnetic force. It arises because of mutual contact between the two solid bodies. At the contact points, the atomic particles of the two bodies stick to each other. And this is the cause of this contact force. Contact force obeys the third law I have stated. A normal component of contact force, that is the normal reaction N, which we have been studying in the previous chapter, Newton's law chapter also. And the tangential component of contact force is friction, small f. Okay. And the law of kinetic friction I have stated. And one more thing I have stated, kinetic friction always opposes the direction of relative slip. Opposes the actual relative slip taking place between two bodies. Fine. So this was the first introductory discussion on friction. And second video I will discuss some more theories of friction. Then I'll take all types of problems. Okay. So let's close it here.